In number 8, we're working with the deck of cards. And we're going to pick 2 cards from the deck. So letter A, what's the probability that both cards were kings? Well, I know it's going to be something out of 52. There are 4 kings, correct? What happens when I pull the next card out? Well, nope, so I'm putting the card that I drew first back. So I still have 4 out of 52 cards to pull from, and that's a big number, right? It's 2652 is our denominator.
Did you do that in your head or did you just say it?
No, I'm wrong. It's 2704. Sorry. All right. Option B, what would be the probability if the first card was not replaced? Okay, so we still start with our kings, and then we don't put that one back that we drew. Right, and we only have 51 cards left as well. What does that do to the probability? Multiplying, whoever just said 7.
I said 7 over.
It shouldn't be 7. We're multiplying. Okay, and decrease our odds.
Yeah.
I think I got different answers on that.
Okay, so our dependent events is what we're going to talk about today. Similar to our independent events, but this time the second event is affected by what happened in the first event. And a great example is what we just finished up in your on your homework on the back. If I'm going to draw 2 kings, but I am not replacing that first card. So I pull the first card, and when I go to get the second king, there are fewer options available to me. Okay, because the first thing has happened. And I am not going to reduce answers, but remember on your homework, for those multiple choice ones, they did reduce answers. So you'll have to math frac your answers for your homework, okay? Letter B, if we're going to draw 2 cards that are red, the first card, how many reds do I have to pick from? And then for the second card, what's that fraction going to look like? Yep, what?
Line A is 2 kings and 4.
Because there's 4 kings for the first card, and then my second card I only have 3 kings left to pick from.
Isn't there's 4 kings in a all together?
Yeah.
One king and 8 all together. So only 2 are
Right, so that's why there's 2 fractions. I have 4 cards possible that are kings for my first lucky king. And then once that's pulled for my second lucky king, I only have 3 of them left to pick from. Okay, so 2 red cards. We had 26 to begin with. We drew 1 and kept it out. So now we're down to 25 cards out of 51.
This card stuff is really confusing sometimes.
It does, yep. And again, I'm not reducing, but on your homework, they did reduce. Letter C, 2 face cards are drawn.
What was a face card?
Jack, queen, or king, the ones with the people on them,
Oh, wow.
okay? So there's a total of how many face cards? 12. We pick one and don't put it back. Does anybody want to see how to do that on your calculator with the fracking?
Don't you just put it in the calculator?
You just,
Yeah,
yeah, the 2652, just like it's been right along.
Oh, I knew it.
Okay, I don't like this formula, so we're going to ignore that. Okay? Sometimes we do. I don't think there's any reason to make it more more confusing than it needs to be. Okay? If you're not replacing, which is the key for dependent, we are not replacing, then your second fraction has to be decreased by 1, both numerator and denominator.
So,
Okay, so we're looking at a jar of marbles. We have some red ones and we have some green ones. How many marbles do we have all together? 20. Okay? We're not going to lose our marbles. This isn't so funny. But when we pull it out, we're just going to keep it in our hand or whatever. So, what's the chance I'm going to pull a red marble first?
8 out of 20.
8 out of 20. I keep that one out. What's the chance I'm going to get a green marble next? 12 out of 19. Okay? Do we want to have a quick conversation now about reducing those fractions, or do you want to just rely on your handy dandy calculator? Okay?
2 red marbles.
Yeah, you are
So, the 2,
So you just multiply.
I don't get how this helps us in this sense, like.
Can I see what the calculator?
Well, that's perfect. Yep. I didn't reduce mine, you did. Okay. If you type this into your calculator and fract it, you have a 24 over 95 if you fract it. And that's fine. Letter B, we're going to go with 2 red marbles this time. And again, we are not putting back. So I automatically know what my denominators are going to be.
So 8 out of
Okay? Numerator, how many reds do I have?
8.
8, and I took that one out and kept it out. So now how many reds?
7.
Okay? And again, I am not reducing, so you may have a different number if you frac it on your calculator. Letter C. We have 2 green marbles that we're going to try to get this time. And again, I can start right out with my denominators because I know I'm not replacing. How many green marbles do I have to pick from?
12. 12.
And I kept that one out, so now I have
9.
letter D. We're going to pick a red and then a blue. Again, I know what my denominators are. Chance of me getting a red is 8 out of 20. And how many blues do I have?
0.
What? 0? How am I going to do that?
You don't.
Just don't come.
There's no blue marbles, so what's the chance that I'm going to get a red and then a blue? 0.
So
0.
there's a 0.
Can't happen.
So if there's a 0 anywhere in our problem, it's a 0.
Correct. Anytime you multiply by 0, it's worth 0. You learned that, I think, in 3rd grade. Here we are using it
Oh,
now
we saw one.
in high school. You're so smart. To the back. We're going to draw a deck of cards again, and please note, no replacement. What's the probability that we're going to get 2 aces?
A 2.
Again, I know my denominator because I'm not replacing the cards. Okay? Numerator, how many aces are there?
2.
There are 4. Correct. And then I kept that one out. So now there's only 3. All right, I'm going to reduce this one old school, by hand. I know. I'm not going to rely on my handy-dandy calculator. I know that 3 goes into 3 once and 3 goes into 51 17 times. I know that 4 goes into 4 once and 4 goes into 52 13 times. And when I multiply 1 times 1, I can get 1. And when I multiply 13 times 17, I get 221. Choice 3. Would you just write this down, even though you may have done it on your handy dandy calculator? Will you just write down my simplifying?
I don't know.
Just write it down.
Is it not?
It won't
It's
hurt. Just write it down.
Wait. 4.
You can even use colors if you want to, like I did.
That involves getting it up.
Oh. That's tough.
It's just such a long walk.
It's hard.
I should I'm really lazy. This is where
Number 4. We have 8 runners that are in a race. 4 of them come from Arlington High School and 4 of them come from John Jay High School. If the runners race at random, what's the probability that first, second, and third place will all be Arlington runners? All right. I know there's 8 runners to begin with, and then there will be 7 left for second place, and then 6. How many Arlington runners do I have that could place in first? And then 3 left, and then 2 left. Check out the reducing for this one. So awesome. I'm gonna go kitty corner and try to get as small as I possibly can.
What do you? Is my calculator fine?
Your calculator is fine, but this one, by the time you push all those buttons on your calculator, this is probably easier. I was talking. Speed. So 1 in 14 chance that the Arlington runners will get first, second, and third place together.
They probably.
So I don't think that sounds like a really great odds, but who knows? Number 5. Erica is talking with Diana about her plans for the weekend. Now, just guessing that when you talk to your friends about your plans for the weekend, you don't talk like this. Erica says, if it doesn't rain on Saturday, then there's a 30% probability that I will be at the beach. And if it does rain, I'm not going at all.
That makes perfect sense.
I feel like if it's rain, I'll be at the beach. If it
Pretty sure. But I'd like to ask you sometime over the course of this holiday weekend for you to throw out some random kind of thing like that. There's a 30% probability that I'm going to the parade on Monday or something. And just see what kind of a reaction you get from your family and friends.
I'll probably get
that was something
letters.
loud. That was something
I'm
loud.
curious to see how that goes.
I'm gonna do it.
I would like to hear back from you. We'll do a little unofficial study. I asked the morning class to do the same thing, so you won't be the only weirdos in SIO talking about percentages and probabilities this weekend. The weather forecast states the probability of rain on Saturday is 20%. Which of the following is the probability that Erica will go to the beach? Well, she said that there's a 30% chance that she's going to go to the beach if it does rain. And we know that the chance of it raining is 20%.
I just bet my
So-
tongue.
There is a 6% chance that Erica will be going to the beach this weekend. Pretty low. Can I use it? Pretty low. One more time, your homework, they did reduce those fractions. Okay, so you're gonna need to do that. Don't be looking for your answer if you didn't reduce, because it will not be there.